Okay, as I showed on the previous video, I'm currently using this type of fuse to protect the batteries from overcurrent, but this fuse has a drawback. It is made of steel, and the temperature at which it opens is rather high, at around 350 degrees Celsius to 400. I will test this other type of fuse. It is made of a zinc alloy that has a much lower melting temperature at around 200 degrees. This one is a 40 amps model, and I mounted here a 30 amps and painted it in black to facilitate to the thermal camera to better read its temperature. And I will monitor the temperature that it will blow. The electronic load fan will be noisy, but the load will work at around almost 2200 watts, so I need the fans to cool it down. Okay. Current temperature is around 30 degrees on the fuse. Let me start the load. 20, 30, 40, 50, 60, 70, 80, 91 amps. Okay. The fuse temperature is rising, 110, 111. Let me put 95 amps. Okay. Fuse temperature is 130, 134, 140. Almost 150. It will melt. Okay. 160. Almost 170. $180. It opens around 185 degrees. That's the fuse opens at 185 degrees. Okay. Let me turn it off. the electronic load fan and the power supply fan. Okay, even if the fuse is rated to 30 amps, it will continue to work at rather higher current. As we saw, it opens at 95 amps. After some 1 minute mark, I will see the video again to verify this time needed to open the fuse. But two conclusions on these tests. I already made other tests with this type of fuse. As we can see here, open fuse. This is a 50 amps one, and first conclusion, an important, foremost important conclusion: the temperature at which this zinc alloy fuse opens is much lower than the steel fuse, at less than 200 degrees. So it is much safer to isolate this temperature inside the battery. Second conclusion, important conclusion, even if the fuse has a 30 or 40 amps rated capacity, it will need a time with a much higher current to short and open it. I will probably use the 30 amps on my batteries, as it can work at 60, 70, 80 amps with low temperature, and will need currents at 100 amps and higher to open it. So probably 30 or 40 amps will be sufficient for batteries for used on tools, electric tools. And now I have to create a way to include this fuse on the battery connections. I had already made some prototypes, and they worked okay. They were here. They were spot welded here, and they work really well. So I will upgrade my batteries fuse to zinc alloy type, as it is much safer and can withstand higher currents than the steel ones. Just to conclude, this original fuse will reach over temperatures at around 70 amps and can withstand 60 amps continuous maximum. And now with the zinc alloy ones, I will have 70, 80, even 90 amps continuous amps capabilities. Some more tests will be done.